Hi there. Uh, Today I intend to experiment with. Uh, Today I intend to experiment with small language model, local installation of small language model, and what I want to do down the road, I would like to automate some of the architecture review process. It would be a collaboration between AI and human, not fully AI and not fully human, to speed up the process. So for that, in that architecture diagram, let's say that's in PNG format. So that image, from that image, I would like to extract JSON equivalent specification from image, and this JSON specification could later be assessed with respect to policy as code, and then alignment or drift could be uh, found out that way. So to set up the small language model, one, there are several options. So QN by Alibaba has visual or image processing capability. It's a smaller language model that could easily run on your 16 gigabyte RAM laptop. So laptop with that RAM, you do not need massive amount of RAM. And uh, I already have Docker Windows subsystem. Those are installed. So what I am doing to begin with, you see that I'm trying to install uh, QN, but I want to make sure that I'm not putting myself in any security hazard, safety hazard. And the model files, if those are coming from untrusted source, or if those are, let's say, in pickle format, there may be malicious code inside the pickle format that could uh, put me in trouble. So I am looking for some model format. uh, uh, there is no malicious code inside that to be executed later. So for that safety, I am trying to create a Docker sandbox, and within the Docker sandbox, I would install uh, the QN model, and it would be accessed via Olama. How I am doing it? Let me show you. So I am doing Bash, and with Bash, I am uh, s- switching to my uh, Windows subsystem mode, uh, apology, WSL mode, and then I am running the Docker command, and then I'm creating a sandbox. And if GPU is available, I am enabling the usage, and then I'm specifying storage location, which port would be used in communication with Olama, and then I'm creating that specific image, and that image is unavailable on my system, so that's getting downloaded. Once that is done, within that Olama sandbox, I would like to have given image processing small language model. So for that, I'm executing this Docker command, and with all those things set up, I also need to make sure that I have Python on my system. So for Python on Windows 11, you would execute winget command, and then I have a uh, Python program. So the image processing small language model is running on Docker. Uh, uh, Here, uh, sandbox, and then I do have a Python program, and then the Python program is running on my host machine, not on Docker. And then here, for simplicity, it is very much hard coded. So from internet, I got a C4 uh, diagram, and the C4 diagram has credit goes to a different site. So this is a C4 diagram showing architecture specification. Different containers are speaking to each other. So we have customer representation, then UI, then backend, and for so and so. From this image, what are the uh, components or subsystems, and who is source, who is destination? uh, I will use a Python program to communicate with QN language model and provide this image, and then as output, all the component name, who is source and who is target, that information or that relationship will be produced in JSON format. So that's the idea. So this is the Python program. And then I had some issue. So by default, the context window is quite small. I had to change the context window parameter here to make sure the program is not not throwing error. So with that, and this image name is hard coded instead of a hard coded image name for your real world work. You will pass the image name as a parameter. So with this, what I'm doing here, you would see I have a Python installed, and then first time I run that Python program, it a Python program. So I am telling that, hey, run this program. Behind the scene, this program is talking to the running Docker Olama sandbox with QN uh, image processing small language model. So it is talking to that. However, the context window was quite small by default, so it crashed. And then I increased the context window. After increasing the context window, this is the output. You will see that it extracted the uh, component name, and it also extracted the relationship. And this file could be used in a later phase to check compliance with organizational policy expressed in Rego language in OPA, Open Policy. Uh, the whole name is not coming on top of my head. So OPA, and in Rego specification, you can match this JSON specification with policy specification to flag to human user that where the, it is failing, where we need to put close inspection or supervision in the architecture specification, basically helping human with review, AI accelerated architecture review. That's the idea. That's all for today. Thank you very much for listening.